Good afternoon, everybody. Thank you for being here. It's a pleasure for me to be here with Pascal and to present this paper and to share with you our experience. So the topic of our agenda we will start by introducing our company. Then Pascal will present the MECS offering and the way we approach the maintenance strategy. I will go on with a case study, replacement of acid towers. Then Pascal will continue with an example of other replacement project. We'll finish then by a testimony presented as a video. So MECS, who is MECS? MECS is an American company that was established in 1917. The company was acquired by DuPont in 2010 and is now part of the Clean Technology division. MECS has a deep experience in designing of acid plants, construction and operation of those plants. Our core business is indeed to provide process technology, including license, and most of the major equipment that are required to build an acid plant. It is a combined experience for MECS, about a century experience in engineering of sulfuric acid plants, and for DuPont, more than a century in operating those plants. A combined experience does that makes that we are the leader, or certainly one of the leaders in the sulfuric acid technology. Through these decades of experience, what can we say about the MECS the plants that MECS design and deliver to the clients all over the world? They are safe because we have a good understanding of corrosion and handling hot acid and steam. They are environmentally friendly, meaning that we will design them to generate low emission, generally the level of emission which are dictated by country or regional regulation. Our plants are also designed to optimize the energy recovery. The MECS plants are known to be reliable and easy to operate.
Thank you, Youssef. So before we jump to the strategy for maintenance, I would like to present a little bit why MECS is your best partner in your plant operation. So this is a little bit MECS team. So we have field specialists on site, which are there to identify problems to plants, and together with the plant equipment specialist and the process people from our engineering team, we are providing a solution to your problems. Now, once the solutions is fine, then the project management team is starting and is building equipment together. Well, is designing first equipment again with plant equipment specialists, with process people and mechanical engineers, and at last we are contracting local partners to build those equipment and install those equipment on site with our field specialists that will make sure that the equipment is starting properly. So that's a little bit how we are operating, and obviously we have a safety team which makes sure that all this is done on a safe manner. So now, what are we offering? This is a typical plant design. Here it's with our HRS system. It's actually the plants that we have built in the ODI plants of OCP. So that's the sketch, and this is a little bit what we are offering. So as you can see, we are offering all what you can find in an acid sulfuric plant, from towers, coolers, pump tanks, and Youssef will talk deeply about towers. On the gas section, we can offer converters, steaming equipment, so kind of everything. Sky is the limit, I would say. And of course, we are not only offering equipment. For each individual equipment, we also provide all the process-related matter, so to make sure that the equipment is operating the best manner. About our experience, here you can see a little bit some achievements over the last century that we have been engineering and providing equipment to sulfuric acid plants. As you can see, the numbers are quite significant from full acid plants to large charge equipment, smaller equipment, and obviously a countless number of hours of field service and customer support activities. Now, let's go to maintenance strategy. So my experience has been showing that you see in plants two types of strategies for replacement of equipment. So one strategy would be to maximize the equipment life and replace the equipment after it fails. Obviously, that brings, that is limiting the investment for that equipment, but you may risk some long plant downtime waiting for that equipment to be supplied. What MECS is recommending is to replace equipment proactively by monitoring the equipment performance during operation, or to perform inspections during shutdown. That will maximize the plant production time. And I will go deeper in those inspections. So, well, this is inspection during plant operation. Of course, during operation, you have many information which is valuable, and the key is first to monitor all your process parameters, can be pressure drop, temperature, acid concentration. All this gives a lot of information on how the equipment are performing. I can give an example. If pressure drop is suddenly increasing a lot in an acid tower, that may be the mist eliminator which has plugged and that will finally completely be destroyed. Other tests that can be done is stick test, simple wooden sticks that we put into the tower to see if we have acid carryover after towers. We can do missampling, or even simpler, looking at your stack. And we can also do, and MECS can support on all this, we can do some Pegasus, what we call, which are SO2 analysis. So we can analyze your SO2 content in different part of your plant. Can be in your converter to see how efficient are your catalysts, but can also be the looking after leaks in your gas-gas heat exchangers or many other locations on your gas section. So that was during operation, and another critical time to perform inspections is during shutdowns, where we physically do visual inspections of all the equipment to look for corrosion, acid leaks, or any type of defects in your equipment. And we can also do some measurement, like measuring your catalyst activity, doing thickness measurement, eddy current testing. So there are many types of inspection that can be done during shutdown, and that we recommend doing this. If you have difficulty accessing some areas of equipment, we have cameras available to look into those equipments. So now I will give the word back to Youssef, who will study the case of replacement of alloy towers.
Thank you, Pascal. So the offering that MECS that Pascal just presented is quite wide. Because we replaced many of them those 2 last decades, especially from our office in Belgium, and because it represents quite an important investment for acid producer, we would like to speak a little bit more about replacing acid tower. So let's start by defining an acid tower. It is a cylindrical vessel inside which a reaction of absorption will take place between a gaseous phase and a liquid phase. In the case of a drying tower, strong acid is used to absorb the moisture that is contained in the process air. For an absorbing tower, interpass or final tower, the acid is used to absorb the SO3, which is contained in the gas stream. A column of packing is used to ensure the mass transfer between the two phases. The gas enters the bottom of the tower and flows upwards in countercurrent to the acid that is distributed from the top side of the tower. Before leaving the vessel to go to the next equipment downstream, the gas or the dry air will pass through this compartment where are located filters. The aim of those filters is to eliminate, to remove the acid mist that has been produced during the reaction. Nothing is eternal. We mean by that everything gets eventually deteriorate. The typical tower lifetime is about 30 years, but after so many years of operation, problem may have already started. Acid leaks may occur more and more often, and they can become an issue for the safety of the workplace. Needless to say that the time and the money to fix those leaks becomes also a big concern. You can see picture of those examples of deterioration. Acid bricks getting loose to each other and making in this picture that the arch is not anymore self-supported. Sorry. The tower is basically an empty shell. Internal components deteriorate as well and will also need to be replaced. You can see picture of cast iron acid distributor full of sulfate. Here, a failure in an aludurbine part of a packing support system in a brick-line acid tower, and here a huge amount of sulfate on mist eliminator. All those internals will have also to be replaced not by equipment in kind, but by better, high-efficient equipment that MECS can offer. So which are the criteria that plant manager will consider when buying a new tower or more generally new sulfuric acid plant equipment? The cost, of course. The performance, production capacity, and emission will have to be guaranteed. The longevity, the new tower will have to last as long as the current one. It must be reliable. Repairability, in case of a leak, it must be quickly and safely repaired. Safety of the workplace, during operation is important, and the time. The question will be, how long will it take to replace the current brick-line tower by a new acid tower, or given differently, is it possible to replace it during the yearly shutdown? The answer is yes. MECS can help acid producer to replace their tower in less time than the duration of a cold shutdown. We can say that because we made it many times for many clients worldwide. So the debate, brick line versus alloy tower, is the classical debate or question that raises every time acid producer have to take a decision. For nearly a century, the acid tower have been fabricated from acid brick. It is in fact a carbon steel shell lined with acid brick and in between an acid-proof membrane. This execution has merits and demerits that all players in the acid industry will agree on. We speak of bricks, we speak of low material cost, but high labor cost. Indeed, you will need highly skilled masons that are not easy to find. It depends, of course, of the size of the tower, but we speak generally of 3 months of fabrication. From the quality standpoint, it is a precision work that must be very well done. From the maintenance standpoint, it is intensive. At least once a year, maintenance people will have to ensure the good condition of the brick and to perform inspection, frequent inspection and repair of the support arches. And in case of a brick failure, it is difficult and costly to repair, and it leads generally to a long time out. One advantage that people of the acid industry will almost all agree on is that brick-line acid towers are operationally very forgiving, meaning that they can handle excursion of acid strength as it happens, weak acids, and it will not have a bad consequence on the mechanical integrity. So why the MECS Z-Corrosion alloy tower are preferred over the brick-line acid tower? Because they have a lot of merits. The first one, they require less on-site construction time. The reason is that the towers will be fabricated in the workshop prior to the shutdown. As I said earlier, and in the case of a replacement in existing plant, they will be quickly installed and on the same foundation after minor repair or adaptation. Because the alloy towers are 3 to 5 times lighter than the brick-line acid tower, the foundation cost will be much more lower. The alloy tower require virtually no maintenance. The only thing that maintenance people will have to do is to measure thickness, and this can be done even during operation. And they are easier to repair, meaning that in case of a failure, it can be quickly and easily repaired by local replacement of the alloy by welding. 2 points that could be seen as disadvantage, but which are in fact not. We speak of premium materials. Alloys are expensive. However, as an offset, less material will be used compared to the heavy brick lines. The other point is that they require operational excellence. The alloy tower should not be operated out of the acid desired strength and temperature. To help in this instrumentation, to control in continuous the acid strength is required. Some of the benefits of the MECS Z-Corrosion alloy tower, when they are properly operated, the alloy tower will virtually not corrode. This means that there will be less sulfate formation in the acid circuit, thus cleaner tower having a high efficiency. There will be low iron in the acid, thus an acid of a better quality. And since there are no brick, no mortage, there will be no risk of damage to acid pump. All those benefits make that the costs and downtime due to maintenance will be drastically reduced. The family of Z-Core alloys, so what do we mean by Z-Core? Z-Core are proprietary alloys that MECS developed exclusively for sulfuric acid application. The first one, the Z-Core Z, is a high silicon austenitic stainless steel that is ideally suited for 93 to 99% strong sulfuric acid. We use it not only to design and build acid tower, but also for other products, like, for instance, acid distributor, pump tanks, acid piping, and also acid cooler without anodic protection on fresh water. The other member of the family is Z-Core 310M that we use specifically for application above where the acid strength is above 98.5%, like it is the case for the gas inlet nozzle in an interpass tower. We use also the Z-Core 310M for high application temperature, like it is the case in the MECS innovative heat recovery system. As it must be done for any metals that one's desire to use for a specific fabrication, the Z-Core alloy have been through a lot of tests in order to verify critical properties, like, for instance, the weldability, or again, the weld resistance to corrosion. MECS engage as well experiment with trace contaminants, since we know that fluoride and chloride have a negative impact on the corrosion resistance. Z-Core Z stands for zero corrosion. It has, in fact, very low proven corrosion rate in strong sulfuric acid. The graphs you can see here shows iso corrosion curve of Z-Core in strong sulfuric acid in function of temperature and acid concentration. What we can see is that Z-Core Z can operate through a wide range of acid concentration, and from cold acid up to 120. The Z-Core Z, we can see also that Z-Core Z is not suitable for this part, so below 90% of acid strength and above 99.5%. We mentioned that in this area of concentration, the Z-Core 310M will be suitable. We can also see that for application, for drying tower and absorption tower application, the range of operating condition is in this area of the graph, and we can see that the corrosion rate will be all the time less than 0.025 millimeter of corrosion per year. We'd like also to mention that this is based on static immersion, but in reality, the Z-Core alloy tower and the other alloy engineer products in operation have shown corrosion results which are matching or even exceeding those tests from the laboratory. Weak acid is the enemy, one of the enemy of sulfuric acid plant. There is a potential risk of formation of weak acid in this area, which is a gas in a nozzle of typical drying tower. Since Z-Core Z, neither Z-Core Z and Z-Core 310M are suitable for this acid strength, MECS is using a lining, which is a proven fluoropolymer, to protect this part, to make sure that it will not be attacked by weak acid corrosion. So to have even the best alloy corrosion resistant is important, of course, but is only half of the story. Process expertise is also even more important. So the keys for designing a good acid tower will be acid distribution that must be uniform and accurate, that must limit the misgeneration, and that must be designed so that the walls are always welded. Gas distribution is also important. For that, we will design and orientate the gas in a nozzle in such an angle to have the best gas distribution, and the contact between the gas and the acid must be optimum. All these will make that when replacing, in the case of replacement of tower, there is also an opportunity to make a reduction, to have a reduction of pressure drop, and we will go then for what we call a high efficiency tower. So what do we mean by high efficiency tower? To put a simple definition, it is a tower with the highest absorption or drying efficiency, with the lowest pressure drop, and with the lowest acid miscarryover. How do we reach that result? By the use of optimum equipment. The first optimum equipment is a MECS packing support grid, which has the feature to be flat, which provides an equal packing height and an equal gas distribution. The selection of a high-capacity packing is also important. We will use for that super saddle, which provides also an optimal mass transfer between the phases. The use of the MECS Uniflow acid distributor that we designed with a density of distribution of 43 points per square meter. This density of distribution ensure the complete coverage of the tower cross-section, including a good weighting of the walls. Mist eliminator can also be upgraded for lower acid miscarryover. So once the process design is done, engineering, mechanical design drawings are completed, we can start with the fabrication. To help in that, MECS works with a network of qualified shops, which are experts in stainless steel fabrication. Not only they are experts, but we will train them in Z-Core welding technique. We will also perform several inspections during fabrication at critical stage to make sure that the quality is in conformity with the MECS standards of fabrication. Transport to site from the point of fabrication, based on the information we will provide to the transporter, like the weight, the size, the number of sections. This transporter will perform the rigging study and determine the best road to follow. So this is a picture of a load at site. Erection on site prior to shutdown. This will be the case for a big size tower, or when there is no available big crane. In this case, we will fabricate the tower in sections that we will transport on site to make over there the final assembly. This slide to explain that the lifting lugs and the shell will also need to be designed for the heavy loads. So the shutdown work start, and we can have two scenarios. The first one, the old tower is small enough, light enough to be lifted out in one piece. This connection and lifting out can be done in 1 to 3 days. The second scenario is the old tower is too big, too heavy, and cannot be lifted out. We will then demolish it on the same place, and this will take more time, from 2 to 3 weeks. 1 to 7 days will be required to repair the foundation, including the drying of the concrete. Some adaptation can be necessary to welcome the new grillage and the new tower. Lift into place, half a day to 1 day. To mention that for small size tower, this can be done with all the internals pre-installed. Installation of the packing support grid also can be done in several easy to handle sections. A word about the best way to design a packing support grid. The key is really to keep the surface all the time wetted. The picture at the bottom here shows, for instance, a poor beam design with dry spot on the bottom face, which will lead to a risk of corrosion. So some benefits of the Z-Core packing support grid: they require no maintenance. There is no risk of thermal shock, we could see in the first picture with the allure beam, and retrofitting in a brickline acid tower is possible. Installation of the Z-Core Z uniflow acid distributor under the MECS supervision. What is important here is to have all the elements of the distributor, acid header and trough, properly tightened to avoid any acid leaks inside the tower. Quickly, some benefits of the uniflow acid distributor. They are easily adjustable on site to specific acid flow thanks to manual gates. Since the troughs are wider and deeper, we can observe less surface disturbance, very good acid distribution, and a good weighting of the wall, which will avoid bypass. They are easily to install and require low maintenance. To finish, installation of the mist eliminator, and here what is also important is to make sure that the elements are properly tightened to the pedestal. So to finish, 3 to 5, yeah, it could be, to 10 days will be necessary to reconnect the piping, ducting to the existing circuit, and to complete the platform around the new tower. Pascal.
We have 10 minutes. Okay, thank you, Youssef. So our equipment have a lifetime, unfortunately, our presentation as well, so I will go quickly through the remaining, and maybe we'll have enough time for the testimony. So I will present other type of projects that we can have. Here it's a converter. So you might have seen presentation yesterday from my colleague Tom about catalysts, so that we can find every shape, every type. We obviously can also provide converters, which is made fully in stainless steel and can be replaced. Can replace old style converters. This is always, like I mentioned, process. There is always a process study which make sure that you have the best conversion in your converter. Okay, we can have piping system projects to replace old cast iron piping. This is also made out of Z-Core and with all the benefits that Youssef presented. Similar as towers, we are providing pump tanks also in Z-Core to make sure we don't have corrosion due to the dilution water and formation of weak acids. We have a specific water dilution system with coated spouter and sleeves. So coolers and heat exchangers. We have our MECS coolers, which can be made out of Z-Core or with anodic protection. We also built shell and tube heat exchangers or Montplex heat exchangers, which are plate heat exchangers. we can retrofit a shell and tube heat exchanger with a Monplex. That is doable. Our HRS equipment, so if you have an old interpass absorbing tower, we could eventually replace this IPA tower with a complete HRS unit, which brings additional to a new tower. It brings a maximum energy recovering in terms of steam. For the furnace, we can provide, well, typically we would not do a complete furnace, but we provide solutions, engineered solution, like vector walls, which are designed to replace typical baffles and optimize the gas mixing in the furnace, all together with a good sulfur gun from our design. On the gas side, we have some critical gas valves that we can supply, slide gate valves, butterfly valves, or jug valves for bypassing the waste heat boiler. And to finish on the other type of big projects, we can also provide waste heat boiler and other economizer, superheaters, well, all steaming equipment. The particularity with our waste heat boiler is that we provide also X-Pro ferrules, which is very easy to replace during shutdowns. Those ferrules are installed without motor, so it makes the operation very, very easy. Okay, that's all for the replacement project, and I would like to conclude with a testimony from one of our Russian customer about a waste heat boiler replacement, if that works. Oh, shit. No. Okay, here we go.
My name is Maxim Petrov. I am the Director of Maintenance and Repairs of the Industrial Group Phosphorate. My duties include the operation of all equipment, supervision of its operations, maintenance and replacement of old equipment. Additionally, we participate in all construction work around the plant. For over 10 years, we had a system consisting of a boiler made in Poland and a boiler section made in the Ukraine. But this did not provide the performance we had hoped for. So we replaced the two boilers with a 150-ton boiler from MECS. And this solved our problems. Currently, we are working with this equipment. Last year, we implemented a large boiler replacement project for the sulfuric acid production. The project was fully developed by MECS. The main piece of equipment we used was a boiler manufactured in India. It was delivered and installed here directly with the help of our subcontractors. There were a number of subcontractors responsible for specific aspects of the project. The main work was done by our subsidiary, Kingisep Rimstroy Service. All work was carried out in time. The boiler was commissioned last October according to plan. With the support of MECS specialists, it was then directly brought up to design capacity and has so far operated at design load.
Okay, thank you, everybody. If you have any questions, I invite you to come to our booth, which is 2829. Thank you.
Thank you, everybody.